Okay, my name is Onur Bulut. This is my video presentation for MIE 375 for Milestone 3. My chosen product was a microprocessor, so I'm going to try to talk about its manufacturing process behind creating this product. I'll start off with the material list. Silicon dioxide. We have this material so that we can create our silicon wafers on which every circuit and everything else is installed. It is basically the base layer, important section of our product. Aluminum, boron, gallium, these are elements and materials that are important for us because they serve as dopants. What are dopants? Dopants are things that we use for increasing the conductivity of our semiconductor or changing its various properties in some other way. Yeah, they're important. Plastics. Plastics are mainly used as an outer shell for our CPU. They're important as well because, well, the product that we have here is very delicate, and we don't want it to get in contact with things that might, harm the very small and delicate circuits on top of it. So, yeah. Plastics are important. Gold, silver, copper, they're important because they serve as the conductive wires for our circuits on top of the semiconductor. Why gold, silver, and copper and not some other material? Well, because these are very conductive metals, and they are, even though they're expensive, the efficiency is important here. So gold, silver, and copper serve better than some metal like iron or aluminum or steel or any other metal. Fiberglass in this case isn't very important, I'd say, but some of the sources that I've looked up show it as a material that is used on conductors, so I added it anyways. Epoxy resin. Epoxy resin is used as a upper layer on top of our conductor as a sort of insulator and a way of actually creating pathways on our semiconductor. It also safeguards certain parts of the semiconductor that we don't want like melting or changing or being subjected to outer factors, really. Here's an image that shows the cycle, I guess, from sand and quartz to pure silicon ingot to wafer, and from wafer to all the way up to a CPU, basically. Yeah, so let's get into the manufacturing process behind this. I know we were supposed to include actually a list of machines and machines that we had to use that were used actually for producing this product, but I was able to find things about the manufacturing process, but the machines that actually do these processes were not very talked about in those sources. Yeah, that's all I have to say about that. Continuing with the actual process, first we have to get our silicon wafer. Well, first of all, why silicon? Silicon is used most importantly because it is a semiconductor, it is abundant in nature, and it is very cheap. So it serves as the perfect material basically for the base of our CPU. And how do we get a silicon wafer? Well, what we do is we use something called the Czochralski crystal growth method. We place a silicon crystal or a silicon seed, a small seed, into our molten silicon bath here, and we rotate this and we allowed the initial silicon seed to grow into a large crystal, and then we cut our silicon crystal to the specifications that we want in order to get our silicon wafer. And this cutting is done via diamond blades, if I recall correctly. Moving on. wafer fabrication. So it's split in two basically. Wafer fabrication and assembly are two different sections of this process. Wafer fabrication in itself splits into various other sub-steps, and I'll be delving into these right now. First of these sub-steps is photomasking, in which we expose our semiconductor into a light, and then we melt the epoxy resin, and we create a pattern that we want to create in order for us to put our pathways and wires into. This is done via this is the reticle that is used. It's like a mask that basically safeguards certain parts of the product and lets the light shine through in other parts. So etching. What is etching? Etching basically is used to remove this thin film from our product and expose the substrate underneath it. How do we do this? Well, we use either a liquid soluble or a gaseous compound, and we remove this thin film to be etched. Moving on, diffusion. Now, what is diffusion? Diffusion is the process of placing our dopant materials into our semiconductor, like the aluminum, gallium, and the boron that I've talked about before. We do this either via basically using high electron beams, or we use either like electron beams or other methods to place it deep into our semiconductor. This is done for the purpose of increasing the conductivity of our semiconductor and modulating its electrical, optical, and structural properties. Moving on, the metal deposition. Metal deposition is where we actually put our wires and whatnot into our semiconductor. This is done many ways as well, like before. We can do it like we can melt the metals and condense it where we want them to condense, or we can use a cathode or an anode to again sort of do the same thing that we did with melting them. Passivation. Passivation is basically the process of sealing the wafer to prevent contamination or moisture entering the wafer to render it basically useless, because this is produced in an environment where like air is cleaner, like a million times more than the normal air that we breathe in the real world. So backlap is the adjustment of the thickness of the wafer, and it's a very straightforward process. Then we move on to assembly. Assembly is also very straightforward, but the most important part about the assembly is the wire bonding. Wire bonding basically connects our microprocessor to the outside world through leads leading into dies and connecting at the bonding ball. This allows for electrical signals to enter our microprocessor, and basically it allows it to function. Otherwise, it will be disconnected from the outside world. So yeah, that is my presentation for this project. Thank you.